Hello, folks. So, welcome to part 25 of Learning Rust series. This is part of my 100 Days of Rust, and I'm on day 12. So, let's get started, right? In the previous exercise, we were looking at the vectors, and I was reading about vectors over here and collections, basically storing a list of values with vectors, creating a new vector, and things like that. And then, so there is some extra stuff over here around using an enum to store multiple types. I'm just going to go ahead and read and understand what this is all about and how it's related to vectors. Vectors can only store values that are of the same type, homogeneous types. This can be inconvenient, okay? There are definitely use cases for needing to store a list of items of different types, okay? Fortunately, the variants of an enum are defined under the enum type, okay? So when we need one type to represent elements of different types, you can define and use an enum. Okay. So, for example, say we want to get values from a row in a spreadsheet in which some of the columns in the row contains integers, some floating point numbers, and some strings. And we can define an enum whose variants will hold the different value types. Okay. This. And all the enum variants will be considered the same type, that of the enum. Okay. Then we can create a vector to hold that enum and so ultimately hold different types. So this is an enum which can hold a value of these types. And then spreadsheet cell int and right. So I think this is the name itself. And then you say text and all that. And then you define int and then you say 3. And then here you say this. So can I change it? Show hidden lines. Okay. Can't change it, but there is a playground, I think. So I'm just gonna go ahead and like check that out. Playground, I'm gonna try this out. Copy this, put this in the playground, and then say print line, and then row, and maybe do this. Let's see if that works. Run, cargo run. Let's just run and see what it says. So doesn't implement. Okay. Well, this has to implement the display thing. Okay, so can I actually go over the values like this for I in immutable vector? I can take it up. Can I do that? So it doesn't know how to print a vector of a spreadsheet cell. Let's see if it knows how to print a spreadsheet cell. Let's see. So for I in immutable reference, borrowing from V, and then you just do this, and then say this. You just need to say I, and that's it. It should give the value. So I. This is not V. Sorry, there's no V. There's only row. And run cannot be formatted. Okay, so this also doesn't have the display. Cool. So can I display this value in some particular way? Colon question mark. No, doesn't implement debug. How do I even display this? Nope. So, okay, I don't know how to display these values. Anyways, we'll come to this. Something to learn. So Rust needs to know what types in the vector at compile time. What does it will be in the vector? Okay, so yeah, I mean, we know that vectors can only have like values of the same type. And when you need values of different types, you just wrap it up in an enum, all the different types, and then use the enum as like the kind of like a single interface to use the other types. So Rust needs to know what types will be in the vector at compile time, so it knows exactly how much memory on the heap will be needed to store each element, right? We must also be explicit about what types are allowed in this vector. If rest allowed a vector to hold any type, there would be a chance that one or more of the types would cause errors with the operations performed on the elements of the vector. Okay. So using an enum plus a mass expression means that Rust will ensure at compile time that every possible case is handled as discussed in chapter 6. Okay. Okay, cool. So it needs to understand, like, to give compile time errors, it needs to understand what operation is, valid and can be performed, right? So it needs to know the types and whatnot. If you don't know, so in this case, I think it's clear that this is a compile time error. Compiling itself is failing for us. Could not compile because at compile time itself, it's saying, hey, it does not implement this thing. So yeah, that operation itself is not allowed because it knows what is the type in that vector and all that stuff. So if you don't know the exhaustive set of types, a program will get at runtime to store an vector. The enum technique won't work. Yep. We have to know definitely like this is the set of types that we will get at runtime. Instead, you can use a trait object. Okay, so something to check out later. This we'll cover in chapter 17. That's way later. And now that we've discussed some of the most common ways to use vectors, be sure to use the API documentation up there for all the many useful methods on vector of t by the standard library. For example, in addition to push pop, you have get and whatnot. Returns the last one. So pop. Okay, yeah, we read this like a pop removes and returns the last one. So dropping a vector is something like I didn't read yesterday, so I'm just going to read that too. Dropping a vector drops its elements. Okay, like any other struct, a vector is freed when it goes out of scope. Okay. Actually, I never read about structs, but we will check it out using structs. Okay. Um, hmm. Looks like there are like a lot of chapters. Anyway, so so yeah, this here it is not defined. Here it's defined. It comes into scope, do stuff, and then here it goes out of scope. So when the vector gets dropped, all of its contents are also dropped, meaning the integers it holds will be cleaned up. The borrow checker ensures that any references to the contents of the vector are only used while the vector itself is valid. Okay. Um, cool. So with that, I'm going to go ahead and go with the next exercise for which I have to remove this I'm not done stuff. And let's see, what's the next exercise? Interesting. So this is the vex2 thing. So there's no error code, so it says expected expression found question mark in line 15 and line 26 at column 9. So it's here, the tests vector loop. Okay, so vector signed integers are the bit. Okay, either do 1 to, okay, I don't know what this is. Interesting. This is a tuple range from, okay. Uh, filter and then x, if x is even, and then take 5 and then collect. Okay, interesting. So answer v dot iterate map given x twice the time of x and then collect and then give that. Okay, there are 5 elements here. I guess this is like all the multiples of 2. So it's 2, 4, 6, 8, and 10. Take 5 and then you collect it. So 2, 4, 6, 8, 10. And then you multiply by 2. So 4, 8, 12, 16, 20. Collect it. Select a loop, clone. Answer is this. Okay. What should vector loop do? So a vector of even numbers is given. Your task is to complete the loop so that each number in the vector is multiplied by 2. Okay, fill this up so that each element of the vector is multiplied by 2. Okay. So we have a mutating thing like here. We say item mutate, so we get a mutable reference. We should be equal to 4, 8, 12. Yep. So we can just, since this is a mutable reference, we'll have to do something like I equal to or into equal to 2, meaning we are mutating this. Performs, so it's Here 12 into 24, so yeah. Returns an iterator that allows modifying each value. Iterator yields all items from start to end. Okay, cool. And what else? So does this pass? I think yeah, that is all good. I mean, not sure if it passes, but hey, let's see if it. If I put 3, does it pass? Okay. However, compilation itself didn't happen, so test won't run. So let's fix this compilation. So vector map. It says filter again multiples of 2 map. It's looking if it's like again multiplied by 2. So you know do the same thing as above, but instead of mutating the vector, you can just return the new number. Okay. So I can just return. So this is an immutable reference. So I can just say num into 2. So now, awesome, the test is fast. Interesting. So, and when I do save, it just goes like this. So, looks like we can do an iteration. So this will actually get, you know, the immutable iterator, and then you can do map. You can do all your functional programming stuff, I guess, map, filter, probably even things like say collect, yeah, to get the whole thing together. So kind of sounds like the Java thing also, and even JavaScript has map, filter, and many functional programming languages do. So takes a closure and creates an iterator which calls a closure on each element. Okay. So this is a closure. Okay. So it says go to map iter. Okay. Interesting. So one moment. Map takes a closure. Okay. And I'm not sure how to understand this, but apparently this is kind of like a lambda or like a anonymous function, a function without a name. And this is the return value of that function, which gives a 32-bit signed integer. And then you collect stuff, transforms iterator into collection. So in this case, you get your vector, and since this is the last line, you can put return or just put this as the last line, and it will pick it up as the return value. Cool, that was interesting. And the interesting part over here is like, you have an infinite range from like you can just say, so the range only bounded, a range only bounded inclusively below, okay, start. The range from start contains all the values with x greater than or equal to start. Wow. So it's like all values from start. Overflow in the iterator implementation when the contained data reaches its numerical limit is allowed to panic, wrap, or saturate. This behavior is defined by the implementation of the step tray. For primitive integers, this follows the normal rules and respects the overflow text profile. Wrap and release. Note also that overflow happens earlier than you might assume. The overflow happens in the call to next that yields an maximum value. As the range must be set to the state to yield the next value. Interesting. So if you have a 32-bit signed integer, there's only so many numbers that this can hold. Like when you iterate over this whole infinite range, and then at some point there's going to be a problem to store it in that. When you iterate over the iterating value, right? Say I here, say num here, and all that. Interesting. Cool. So we also know the mod operator now. And we can say take first 5 elements, creates an iterator that yields the first n elements or fewer if the under. Oh, so if there is lesser, it just takes lesser. Or the end of the iterator, or the end of the zero if happens first, the returned iterator is prefix of length n. It contains at least n elements, otherwise it contains all of the elements on the other. Okay, cool. So I guess that's all I had for this exercise. I'll see you next one. Bye bye.